Problem number 32. You throw a ball toward a wall at speed 25 meter per second and at angle theta naught equal to 40 degree above the horizontal as shown in the figure. The wall is distance d equal to 22 meter from the release point of the ball. And here we have to answer for these four questions. Part A, how far above the release point does the ball hit the wall? That means we have to find the answer when the ball touches this part, what should be the maximum height. So that means this value. So delta y value we have to find. And the second part, that is B part, we are going to find what is the horizontal component of its velocity. So what is the horizontal component? V of x value we have to find. And third part, we are going to find what is the vertical component of its velocity. So that means we have to find V of y value. And in the D part, that is our fourth question, when it hits, has it passed the highest point on its trajectory? So that means we have to answer for this D part after we got the answer from C part, because it's exactly depend on the answer what we are going to get from the part C. So let's answer one by one. So first we are going to find the answer for delta y. That is the answer for our first question. Let's write the given first. So what is given in the question? Initial speed value is given as 25 meter per second, and then the theta naught value is given as 40 degree. And the distance from the throwing point to the wall, the value of d is mentioned here as 22 meter. So we have to write all the given first. Now what I'm going to do for finding the answer for delta y, that is our first question, I am going to use the second equation of motion with constant acceleration. And I have to change that equation in terms of vertical axis, and I have to replace the acceleration with a free fall acceleration. And here the ball is in the air, so we have to consider the g value as negative. So what is that second equation? Delta y, which is equal to v naught of y multiplied by t minus half gt square. So why I just put v naught of y? Because in the vertical axis we have to consider the y component, which is a sine component. So here I have to expand this equation. V naught y, which is equal to v naught of sine theta naught multiplied by t minus half gt square, which is equal to delta y. Let's substitute the value here. We already have the value for v naught, so therefore delta y, which is equal to 25 sine of 40 degree. There is no information about the time t, so we just leave the t here, and minus g value is 9.8. So 9.8 divided by 2, we got 4.9 t square. So now if you want to get the answer for this delta y, first we have to get the answer for the time. For that, I'm going to use the position equation with respect to x-axis. So what is that equation? The position equation based on the x-axis is given by x, which is equal to v naught cosine theta naught multiplied by t. And I'm going to rearrange this equation in terms of t. So by that, t equal to x divided by v naught cosine theta naught. And here what is x? Here x is nothing but, let's go back to the figure. Here x is nothing but the value of d, because we write the position equation with respect to the x-axis. So here the value of d is nothing but the value of x. So what I'm going to do, I have to use the same value of d here. Therefore x, which is equal to d, which is equal to 22 meter. Now I'm going to substitute the value t equal to 22 divided by v naught value is 25 cosine of 40 degree. So here I got the answer as 1.15 second. Now I have to take this t value, then I'm going to substitute the value of t in this equation. So let's write the equation here. what is the equation for delta y? So delta y, which is equal to 25 sine of 40 degree, and the t value, I have to substitute this value, multiply by 1.15 minus 4.9 multiplied by 1.15 square. So let's solve this part first, and then I'm going to find the answer for this, and then we can subtract. So therefore delta y, which is equal to 25 multiplied by the sine of 40 degree multiplied by 1.15. I got the answer here as 18.48 minus, then I have to find the answer for this, 4.9 multiplied by 1.15 square. I got the answer as 6.48. So therefore delta y, which is equal to 12 meter. That is the answer for our question A. So let's go back to the diagram. So the value of delta y, so when the ball hits the wall from the throwing point to the distance, what's the height? Which is 12 meter. Now we have to answer for part B and part C. The equation we already studied from chapter number 4 while we studied the projectile motion. So let's rewrite the equation directly. For finding the velocity in x component, that means the x component velocity is given by the rule v naught cosine theta naught, and then for y component of the velocity is given by the rule v naught sine theta naught minus gt. This is the rule. So let's substitute the value, then we will get the answer for part B and part C. So here part B, I'm going to substitute the value. V naught value is 25 multiplied by cosine of 40 degree. So 25 multiplied by cosine of 40 degree, I got the answer as 19.15 meter per second. So 19.15 meter per second, that will be the answer for B part. Likewise, I have to find the answer for the C part, which is nothing but the y component velocity, which is equal to 25 sine of 40 degree minus 9.8 multiplied by 1.15, the time we already got from the first part. So let's find the answer. 25 sine of 40 degree is 16.06 minus, so here 9.8 multiplied by 1.15, which is 11.27. 16.06 minus 11.27, the answer is 4.79 meter per second. So that will be the answer for V of y. Now we have to go back to the D part. So the answer I told you already, for getting the answer for D part, it's entirely depend on the answer what we get from C part. So for C part, we got the answer here as 4.79. So what answer we got? We got here as 4.79 meter per second. So here what they ask, when it hits the wall, has it passed the highest point on its trajectory? In chapter number 4, we studied when the object reached the highest point of the trajectory, what should be the velocity component in y, which is exactly equal to 0, right? But if you see the answer from C part, we got the answer of V of y, which is 4.79. So that means the answer for the fourth question, the ball does not reach its highest point. Why? Because when it reaches the highest point, its V of y value should be equal to 0. So what should be you have to return for the D part? We have to answer no, the ball does not reach the highest point of its trajectory. What's the reason? Because when any object reaches its highest point, its V of y should be equal to 0, right? But what answer we got in C part? In C part, we got the answer as 4.79. So that's the reason we said the ball still it does not reach the highest point. So this is the answer for the D part question. Clear? That's it. Thank you.